really enjoyed connecting with Digible because of the cool stuff that they're doing. The Dave and Reed and the team that they put together is just fantastic. So I appreciate the invitation here. God, let me get my picture off of that. That's scary. Okay. So anyway, yeah. So what I'm going to talk about today is using data and analytics to drive decisions. Okay. And as Reed suggested, machine learning and AI can be a part of that. I don't necessarily have to. So I'm going to hopefully dispel some of the mystery around those things. So that's me. As you can see, I can't keep a job, okay? So I've done, I've had too much fun. There's too much going on, too many things that keep popping up. But a lot of what I've done has been around data and analytics. And I did, when I retired out of the Pentagon, I was a senior analyst there. And so I've had fun playing with this stuff at the highest levels and with startups. As you can also see, I can't say no to a startup, and I've had a lot of fun doing some really cool things there. So there's just a background of a little bit of my background and where I'm coming from on this. So I'm just going to give you my perspectives on what all this is about. Okay, so we collect more data every day as a species than we did through when? Through 2003. That's a lot of data, isn't it? Except that this slide is completely accurate. It is also completely wrong and misleading, because this slide was absolutely correct when I typed it first in 2011. And so let me give you the end of 2016 update. Okay. This is just growing faster and faster and faster. And yep. Since that slide, into 2016, we've collected 90% of all the data that we have today. All right. Now, I get it. Most of those are middle school girls' pictures of their breakfast that are floating around the internet, okay? But that's still part of the corpus of data that we are collecting. There's a lot of data out there. Who cares, okay? Companies, and I know you don't think I'm this old, but I remember when companies were having the following discussion. Should we get some of those computer things, those PCs for our office? Okay. And an argument that I personally heard physically was, you know, those dot printers, those dot matrix printer things, they don't go through all 3 carbons on our supply forms. So we better keep our typewriters. Okay, so I remember those conversations. I'm actually older than that. So those were in the early '80s. Everybody's automated. Everybody's got their data right now. Okay. So what? What are we doing with this? And this is the frustration that I see with so many organizations when I meet with them, and I look under the hood and see what they're doing. And here's all our data, and how are you using that in terms of making decisions? And a lot of cases they're not. So here's what it means for us. Is this not all we do? We have questions. And we make decisions around those questions. Let's do this. Let's do this. Let's open up in this market. Let's change, move our facilities. Let's redesign our factory floor. Let's adjust our supply chain. Let's do whatever we're going to do. Those are simply decisions based on questions that come up. Okay. How has it always been done? Okay, for forever, I guess. How do business leaders who get paid for making decisions make them? Okay, well, they've got their experience. They've got their gut feeling. The hippo method is my least favorite, but it's usually what, in my time in the Pentagon, that's what I saw, okay? And certainly, there's a huge science around the decision-making process. People have studied that in business colleges for years. People have tried to put those things into practice for years. So there is a lot that goes into business decision-making. This is double feeding. Okay, there's a trick to this. You just got to be real quick. This just adds another element to it, okay? The element of using analytic models, leveraging your data to help make better decisions. That's all this is about. Of course, it's gotten a whole lot of buzz in the last couple of decades. You can't pick up the Wall Street Journal without reading about big data and machine learning and AI and all this cool stuff. It's just another element to help us make better decisions. But it's one that can give us a whole lot of benefit. So, what's the process? Okay. The process is a little different than the other 4 methodologies I had up there, okay? You know, the hippo just, gets briefed very quickly on here's a decision we make and makes a decision and we're done, okay? Using his gut, using his experience, whatever it is. There's a little bit more of a process around leveraging your data. And it starts with, again, asking the right question. That's where every business decision starts, okay? And now we're going to make sure that we've got the right data. So we're going to collect data around the decision that we're trying to make. Hopefully we have data that's relevant to what we're trying to do. And we'll build a model. We'll put a model together. It could be something very simple. It could be something very complex. We'll get into that in a few slides. We'll interpret the results. We'll say, okay, what do the results of this model tell us? And based on that, we're going to make a decision. And I might say right here, this might instead be inform the decision. Sometimes you're going to build a model, you're going to use your data, you're going to look at your data, and the decision's going to make itself. Other times it's going to be a little squishier, and you're going to look at it and say, well, okay, the data suggests this, but some of our gut feeling about our market suggests this, or whatever it is, okay? And so this is just, again, one element of it. And then once you've made that decision, you're not done. You continue to check. You can continue to collect more data. You continue to collect data on that question, and you continue to ask the right question. You go back and you say, okay, how can we make this better? Okay. It's my opinion that when the C-suite is putting their heads together to ask tough questions, that they need to have an analyst there. And one of the reasons is a lot of our current leadership and a lot of organizations today don't know what's possible. They don't know what they can do with their data. And so it's nice to have somebody there to inform them. I'm obviously not talking about Digible, where the core of the leadership in Digible are immersed in data and analytics. Okay? You also have to have someone there from your data team who knows what data sources you have available, whether they're internal or whether they're external, something you got to go out and get. And then building the right model. And there's a whole lot of options there that we're going to talk about. So here's just my view of the landscape. On top we have data sources, and this is obviously an eye chart. I can't see it from here, so you certainly can't see it from where you're sitting. I'm going to talk you through this real quick. Where at the most basic, we've got what? I know no organizations have this anymore, but we got a whole bunch of spreadsheets that are all spread out over the organization, and that's our data, okay? How many times have I seen that in the last week? Or we have more sophisticated data structures where we have a data warehouse full of SQL tables or whatever it is. And here, this wheel here in the middle represents social media. If you were to really squint at that, you'd see there's about 400 different social media sites here in the United States, and most of them are up there. And then we have these global systems and these systems that are all connected by satellite that we can tap into. So there are data sources from sitting on your laptop at your desk, all the way up to something that you can access through government sites, through Department of Commerce, whatever it is. Okay, so there's a lot of data sources out there. What are we trying to do with them? We're trying to run that data through some type of analytic machine where we can get some analytic output. And what does analytic output look like? Well, it can look like over here, like a SQL or like an Excel table, just a spreadsheet. Or we can have cool pictures, dashboards. I train analysts to take data and run sophisticated models on them. And a common comment I get from my alumni is, you know, I've got all these great skills and I'm a dashboard monkey. But sometimes that's as far as organizations have gone. And but we can draw pretty pictures. We can draw pictures. Or we can run more sophisticated models and get some forecasts or some deeper insights. Or this one here, if you were to really squint at it, would represent an artificial neural network that would be at the basis of machine learning algorithm. And over here, as far to the right, we've got AI systems where the system itself, the algorithm, is actually making its own decision. It's learning for itself and thinking for itself. So we have very basic outputs, and sometimes this is all we need, and sometimes this isn't enough. Okay. All right. So what I want to do is kind of break down what I see as the possibilities, and I'm going to go from very simple to very complex here. But I think before we talk about artificial intelligence, it's probably important to talk about what descriptive modeling is and what analytic modeling is in machine learning or deep machine learning and artificial intelligence. Because I think this is my own breakdown of what's out there, but I think it's pretty common to think of the analytic possibilities in these terms. So, descriptive modeling is something as simple as a numerical description of your data. You know, what's the average number of hits that one of our potential customer makes on our website before they convert, before they submit an application? The average. It's one number. We've collected a whole bunch of data. We break it down to one number, and sometimes that one number is useful. It's all we need. Okay. Or okay, here's a distribution of the number of hits that we get before conversion on our website. And sometimes it's less than 10, and sometimes you'll notice there's a long tail that goes up to 100 or 200 people keep coming back before they make their decision, okay? That's descriptive modeling. What's going on in the data, okay? Analytic modeling. Models that find relationships in the data. Okay, we've got, and I'm going to make up a number here, 10 marketing channels, okay? And of those 10 marketing channels, if somebody's only hitting one or two of those channels, we're probably not going to get a conversion from them. Okay, but what we've noticed in our data is that, oh, if they hit this channel, then this channel, then this channel, oh, there's somebody who's interested in it. That's probably someone who we want to reach out to. Because now we can find relationships that tell us that that set of behaviors leads to what we want, which is a conversion. Okay? And so those are those two slices of analytic modeling have been around for a very long time. Okay, we've gotten much better, particularly at this one, because we've got a whole lot more data and we've got better machines that can do things quicker. Now let's get into these last two, deep machine learning. Some people call what I just described, some people call that machine learning. I'm a little bit more of a purist. I don't consider running a regression model to be machine learning, although there are people in my department in the business college who will call that machine learning, and I don't argue with them. But deep machine learning has a very specific definition, and that's when you run very complex data sets through very complex algorithms. And the difference here that I'm going to distinguish between this and this is here you know what the algorithm is. Here, and we'll talk about this a little bit later, you don't know what the algorithm is. Okay? The machine has learned from data. You fed it a lot of data. It knows what to do, or so it thinks. Okay? And it's making those decisions for you, and it's drawing those insights for you, but you don't know how. We don't know what it's doing underneath the hood. And then take that one step further to AI. AI was, when was the term AI coined? When did they come up with that? In the late 50s at a conference in Dartmouth, when a guy named Marvin Minsky and about 6 other absolutely smart folks got together and they said, here's where we can go. And so since the late 50s, AI has kind of gone like this. Hey, we got this great idea, let's do some AI stuff, and then it doesn't work. And let's do some more, and it doesn't work. And it keeps resurging because it's a great idea, it's a great concept. But until very recently, we have not had the type of computing power that it really takes to build AI systems. And guess what? We finally do, but we'll still talk about some of their shortcomings. So back to the same 4 slices of analytic methodologies. What do we do with the first ones? Well, we look at what's happening. Okay, we look at the data and let the data tell us, okay, here's what's going on. Okay, explanatory, descriptive. Okay, is that important? You know, is a dashboard important to you as a business leader? It better be. You better know what's going on in your business. And what better way to do than take the data that you've got and turn it into a story. Okay. Take it a step further, analytic modeling, where we can take the data and run it through a system and do what? Not only describe and explain, but predict or prescribe. Predict or prescribe. Does that sound familiar? We're going to talk about Fiona here in a little bit, but does that sound kind of like what Fiona does? If you do this, here's what the result will be. Okay? Yeah, predict. But you know, if you want to do this, here's what you should do. Here's how you should divide your marketing budget between these different channels. Okay, it's prescriptive. Machine learning does the same thing here as this, but does this for what we're going to talk about, what I'm going to describe as, quote, hard problems. Problems that are very complex, problems that straightforward algorithms just don't allow us to solve. And then finally, AI, when we get there, take your hands off the wheel and let it go. Let it make those decisions, okay? Let it feed the data to it, let it think about that, let it learn to learn, and let the system make decisions for us, okay? All right, some examples. So we've already talked about some descriptive modeling, numerical summaries. Okay, here's the average number of website hits that we get before somebody reaches out to us. Okay, if they're getting close to that average, let's tweak them a little bit. Let's send them a note or something. Okay, dashboards, whether it's Tableau or Power BI, those are the 2 ubiquitous ones right now. But the dashboards. Here's a picture of what's happening in your organization. Here's a bunch of charts, and here's what the trends are, and here's what else is going on. Okay, take it a step further. Analytic modeling, segmentation, clustering. Who do you want to cluster? Your potential customers, your market, your tenants. Okay, well, here's a set of tenants who behave this way. Okay, so we're going to treat them that way because that's what works with them. Here's another set of tenants who behave this way. Let's do something different with them. Okay, so you're not wasting your time, not spinning your wheels. You're not trying a one-size-fits-all solution to your client, your customer base. Okay, finding relationship in the data, forecasting. Okay, which is exactly what Fiona does. And there's a lot of great packages out there. A couple that are very, very powerful and very, very free. Python and R, for example, that do this for you. Okay. And then get into deep machine learning, where we're talking things, and I won't get into the details, but artificial neural nets, and genetic algorithms that are running underneath the hood on these things, where when those things implement themselves, we don't know what's going on anymore under the hood. They're solving, but these are for analysis of very, very complex and often unstructured data. Okay, image analysis. If your organization wants to scrape YouTube to see what videos might be mentioning your product, okay, that would take an individual a whole lot of time. An algorithm can do that very fast, but you better have some really good computing power and a very smart algorithm that can identify your product in a YouTube video. Okay. And taking that a step further because artificial intelligence has as its basis machine learning, but the step that it does is the system is allowed to learn. It's allowed to learn from things that it's never been trained on. It learns from its environment. And that's a tall order, even with today's technology. Okay, what for? What do we do with descriptive modeling? You get a snapshot of your business. You explore current trends, recent history, to see what's happening, what's gotten us to where we are today. Analytic modeling, okay? How do we take it a step further? How do we optimally allocate our marketing budget based on what's happened in history? Where is the market going? How are things trending? Let's make a forecast. And thousands of others of applications. Machine learning, image analysis, natural language processing. Let's scrape Twitter and figure out what the current sentiment is on this topic that might affect our performance in the market. Okay. And then AI. Those are really the hard problems. Can you program every road condition into every car and have them self-drive successfully? Of course not, okay? But that's what we're doing with it. We're letting it learn from its environment and letting it make decisions. Sometimes, as we'll see here in a second, that decision is, I've never seen this before, so oops, okay? And so we're not quite there yet, but we're getting there. Okay. And again, what are the strengths and pitfalls? So nice thing about descriptive modeling, it's quick and simple. You've got your data. Here's the average number of hits we're getting. Here's the profile of our demographic profile of our customers. It tells a very quick story. It's very easy to do from existing data. The problem is those snapshots might be anecdotal. Okay, you might pick something up in the data and, oh, that's kind of unusual. Yeah, it really is unusual. It's never going to happen again. Don't worry about it, okay? Even though it shows up on your chart. And that's the things, unfortunately, as humans, those are the things that catch our eye. That's not like everything else, and you obsess on that when you should really be ignoring it, okay? Analytic modeling. It's very powerful, very effective. Been around for a couple hundred years. Actually, most of the statistics is about 300 years old. Multiple regression is about 100 years old. Some of the more sophisticated and kind of sexy algorithms that we're running today might have been developed 50 years ago or more. But it's been around for a while. These things work. They really do give us good insights into what's happening in our data. But the problem is our data's gotten so complex recently that these straightforward techniques don't work very well on a lot of today's problems. And then deep machine learning. These are, like I said, these are the hard problems. These are the ones where you have so much data that you can't just run it through a straightforward algorithm. You've got to take the data and train the algorithm with your data, with a lot of data. And that's a problem. You really need a lot of data. I'm going to give you a quick example of a really neat machine learning algorithm that I'm going to give my institution a shout out, even though I'm going to give a shout out to the engineering college. So our computer science department was developing a teddy bear. Okay? And here's the teddy bear. The teddy bear is for autistic children. And the teddy bear sits there until the autistic child approaches it. And as it notices that the child is approaching it, it greets the child. Good morning, Tommy. Why are you so sad? Good morning, Tommy. What are you so excited about? Good morning, Tommy. Why are you so happy this morning? Good morning, Tommy. You look puzzled. Okay. How does a teddy bear know what Tommy's mood is? What his current sentiment is he's walking towards that teddy bear. That's where interns come in. The reason I'm so familiar with this is when my daughter was an undergrad at DU in the computer science department, she did a summer internship with the Teddy Bear Project. And she personally looked at 60,000 images over the summer and classified each one of them. Here's a scale from, it was a clock, it, started at 12, went all the way back around to 12, and it was kind of a continuum of sentiments. And she would look at an image and she would classify that image as puzzled, upset, happy, excited, scared. And when they had several million images classified, this was a lot of interns, they could feed those into the software for the teddy bear. And the machine learning algorithm decided, okay, here are the facial characteristics that we are going to associate with those different moods. So to me, that's a great example of a machine learning problem. But what did it take? It took a whole lot of labor to build the dictionary of what those facial expressions really mean. And it took human understanding of that before we could program it. Okay, so is lot capitalized? Yeah, okay. I had to make sure. A lot of data. Okay. And for AI, AI can take care of tasks for us. It can, it can drive our cars for us. It can, it can order our pizza for us. It can do whatever we want. But what's the pitfall of AI right now? We're not quite there yet. Okay, we got a ways to go. So, why did I go in this order? Oftentimes, descriptive modeling is all we need. You take a snapshot of your data, and guess what? That's all you need to know to make your decision. You look at that dashboard and say, oh, wow, we've really gone south on this. We need to put more attention here, or we need to, we need to adjust our decision-making process around what we just learned from our data. Analytic models, they work. Sometimes you do come up with spurious effects. Sometimes you come up with relationships that really aren't there, okay? And you might think they are because the model just told you, and you're going to make a decision based on the wrong reason. It may not always be the wrong decision, but you may be making decisions on the wrong reason. Deep machine learning. Okay, that's a black box. The classic image analysis program or problem is tell the difference between a cat and a giraffe. Okay? So in order to train a machine to tell the difference between a cat and a giraffe, we have to feed that machine images. Okay? Here's a cat, here's a giraffe. And then the algorithm's going to build itself, this artificial neural network sitting behind the machine is going to be updating stochastically until it gets really, really good at identifying cats and giraffes. Okay. How many images does it take to train a cat and giraffe detector? How many images do we have to feed into that machine to make sure that with 99.999% accuracy, it's going to tell you what a cat or giraffe is? It's 3 to 5 million. That's the kind of data we need to train machine learning algorithms. And oh, by the way, if you show a 3-year-old a picture of a cat and a giraffe, how are they going to do? Okay? And they haven't seen 3 to 5 million cats and giraffes. That's why this is so tough. Google Images does some great things, but you know what? Google cannot tell you the difference between a parking lot and a tennis court. I don't know why you need to know that, but it can't get it right. And my favorite one with Google Images, it often classifies pictures of green grassy hills as sheep. And the reason is because every picture of sheep it's ever been trained on, the sheep were on a green grassy hill. And so it's picking up something that we don't know. There's something about the green grass hillish part of that it's associating with sheep that none of us would call a sheep. And AI. Again, we're kind of silly because we will tolerate 35,000 auto fatalities with human drivers in it. And how many self-driving car fatalities are we willing to tolerate? Zilch. We're not happy with that. It doesn't make us comfortable. You know, even though 35,000 of us are going to die this year with from human error. And what was the latest? What was the most recent fatality with self-driving car? Going up a hill, blue sky in the background, white van came across the field of vision, and what did the car do? Kept going. Why? That's a cloud. That's a cloud. That was a cloud because it knows that against a blue sky, a white object moving is a cloud. And it said, okay, we have no way of knowing that that's what the algorithm is thinking until it makes this mistake. And my favorite, Watson is smart. Watson could win Jeopardy, it could win chess, it could play Go like no human can. They tried to train Watson. So Watson by itself, I believe, as a medical diagnosis tool would be very effective. Here are a set of symptoms. Here, make a diagnosis. Okay, well, how's it going to do that? We're going to feed it millions of patients worth of symptoms with the correct diagnosis identified. And sure enough, it's going to say, oh, well, this looks like that, and this looks like that, and this looks like that. But IBM tried to get clever. Watson has natural language processing built into it. So they fed Watson all of these medical journals. Said, read these medical journals and figure out what's going on and make better diagnoses based on what's in these medical journals. Right now, the worst doctors are by far outperforming Watson in terms of making diagnoses. It's not there yet. I personally believe they tried to get too clever, and by putting that AI capability in, I think they kind of made a mistake. And they know that, and they're trying to fix it now. And who remembers Tay? Oh, I love Tay. Tay was the Microsoft chatbot. Now who remembers Tay? Had to shut her down after how long? 24 hours. They put Tay out there. Tay comes on and says, hello world, and everybody in the world was allowed to chat with Tay. What was Tay saying at the end of 24 hours? Hitler was right, kill all people. Yeah, why? I'm not going to suggest that any of my family members are internet trolls, except for my daughter, who's a CS major, who wrote her own bot to train Tay. But millions of people were training Tay to be vile and horrible and terrible, and that's what Tay became. And after 24 hours, Microsoft was really, really embarrassed because their AI system, which simply learned from conversations with other people, was trained by a bunch of internet trolls. Imagine that. And she turned out to be really, really bad. Okay, so AI, be a little skeptical. Okay. Oh. There's the landscape. So what? Who cares? Come on. I'm not ready for Rocky Horror yet. All right. So let me try to put this in perspective for you. We're getting results from Fiona. What are your expectations? My guess is, as a Fiona user, it's pretty much a black box to you. You put in your parameters and you say, here's what I want. And Fiona gives you some suggestions, and you're not going to know how those suggestions are coming about, okay? Certainly Reed and Dave do, okay? The Digible team does, but as a user, you're not going to necessarily use it. What if you disagree with what comes out of Fiona? What if you disagree with the results of analytics that you're receiving, okay? And how can you check? So, all right, what can you expect from analytics? My personal view is over 50% of analytic efforts produce nothing. That's all you get out of them, okay? You took your data, you tried to get an answer out of it, and the answer wasn't there, and oh well. However, overall, analytics gives you about a 13-to-1 return on your investment when you use it. Okay, that's including the 50% that pays nothing. So, what I would suggest is start by collecting your own data. What did Fiona suggest? Or what did any tool suggest? And did I follow that recommendation? If I didn't, what happened? If I did follow it, what happened? Don't just use it blindly and move on, but go back and check. Ask the question, what happened when I did what it suggested? Did I get the occupancy rate that was forecasted based on those actions? Okay. What was the forecast? How accurate was it? I did what they said. Did it work? Okay. We have multiple channels getting recommended. Which ones led to a conversion? Can you check that? If you can check that, are you maintaining that data? If you're not maintaining that data and you can, you should. You should know how things are moving around in your business. And does it seem to be working? Does it seem to be at least in the same ballpark? Does my gut feeling tell me that's pretty much what we should have gotten? Or are you driving into a white van against a blue sky? Take it a step further. You've got the data. You've got the recommendations. Conduct your own experiment. And this is, okay, it's kind of hard to do if you only have one property, but if you got multiple properties, okay, adjust some auto parameters. Let's try tweaking this one over here and see what happens. Let's try tweaking this one over here and see what might have happened, okay? Let's do exactly what they told us over here and see if we get the same result. Conduct experiments with it. Go into it, challenge it, make it think. Make it justify its decisions to you, okay? And then find out where the prediction and your results differ. And see if you can tweak those inputs and see if you can get better results, or you could figure out what's really making it tick. But collect the data, keep the data, and analyze the data that you got. Take a look at it. Just build a dashboard. Draw some charts. Ask the question: what's happening with our data? What did it say would happen, and what actually happened? Okay. Did I just have that slide up there? Up. But be careful. This is a hard problem. Why is it hard? Because you have nonlinear effects with the amount of budget that you put in any one marketing channel. If you don't put any budget into that marketing channel, you don't get any effect. But as you put more, you get more and more, and then you start getting diminishing returns. So you have very nonlinear results here. We have the interaction for marketing channel. You might reach a conversion after one of your potential customers, potential clients, hits 15 different marketing channels, or hits 5 different marketing channels, or hits 2 or 3 different marketing channels. And that's what it takes to drive a conversion. And of course, all the data are interrelated. Can you, as users of Fiona, help improve it? Absolutely. Share your results. Hey, Reed, Dave, you guys told me to do this. I did this. Here's what happened. Here's what you said was going to happen. Hey, it's actually pretty close, isn't it? Or, hey, in this case, it was way off. What's going on here? So when you get a recommendation from a machine, go back to the people who are building that machine and suggest to them, this worked really well. Let them know what's working. Let them know it's not working. Share your expertise. There could be a black swan. Okay, well, geez, we didn't get the occupancy we were shooting for, even though it told us we would. Oh, yeah, but the factory closed down. Or they did immigration raids, in that factory that morning. No, that never happens, except for this morning. That first day of school. So again, you're the ones on the ground who knows what's going on and who know what might change things. Collect your data, analyze the data, put your judgment into it, and see how it's working for you. So that's my kind of take on the landscape. We've all got data. We know that. We know that we can do something with our data. Hopefully we're doing that. Many of us are using what I consider to be a really sophisticated, very cool product. That's what Digible's built for us, and it's fun to watch it work. But don't use it passively. Don't use your data passively. Don't use analytics passively. Be a very discerning user. Question it. experiment, and certainly give feedback to the folks who are building those products for you so they can make them better.